Question number 23. The failure time of an electronic component is believed to be exponential. A exponential random variable. A component life test is performed. Exactly one component is in operation all time, and in the event of a failure is replaced. Observation begins at 0 and ends at 10, and there are 12 failures, and we need to work out the 95% left-sided confidence interval for the mean time to failure. Okay, so what information have we got in here that we can use to answer the question? Firstly, the most obvious is time is from 0 to 10. So let's say that t is equal to 10. We had 12 failures denoted by R. It's a 95% confidence interval, so alpha is equal to 0.05, or 1 minus the probability. Which of the following, what else do we need here? We need to know that whether or not it's a time terminated or failure terminated test. Well, in this case we've been told its time is 0 to 10, and during that time 12 failures occur. It doesn't say that the 12th failure occurred at exactly 10 seconds, so we can assume this is a time terminated test. And that implies that we don't use degrees of freedom of 2 times R. We use degrees of freedom is 2R plus 2, or in this case 2 times 12 plus 2 is 26. So if you look to the relevant equations in the 2013 formula sheet, which are equations 73 and 74, which you'll find on page 6 of that set of sheets, if you look in the validity and conditions, it'll give you the answer to this. In the equation itself, it's used 2R for the chi-squared table lookup. But then you'll notice in the conditions it says if it's a time-terminated test, you use 2R plus 2, because we've added some degrees of freedom to the test. So we've pretty much got everything we need. All we need to do now is work out which one of those equations we need to use so that we go and look up the right number in the formula. Well, in this case it's pretty easy to figure out, because all of our answers that have been given are from a fixed number to infinity. So we're obviously looking for a mean time to failure greater than a certain number. But I like to think of it as a left-sided test, meaning we want to fix the left side of it, and then somewhere the answer that we're looking for the right uncertainty is to the right of that number on a normal timeline, or a normal number line. So I don't know if that's what it was intended to mean, but that's the way I like to think of it. So in this case we're going to use equation number 74, and it says that the mean time to failure is equal to, well, greater than or equal to, that's ugly, is greater than or equal to 2t over the chi-squared from alpha with, it says 2r, but we're going to use 2r plus 2, and that is equal to 2 times t is 20. Now I'm going to the chi-square table, which is the last page of all of our formulas this year, and we need alpha of 0.05, and coming down, and we need 26 degrees of freedom, so the number is 38.885. And so this is going to be our critical value, 20 divided by 38.885, and that gives us 0.514, and that is the answer that we were looking for. Well, not quite the answer. That's the left side of the answer we're looking for. So the actual confidence interval, if you had to write it out, is, well, you're given the answer there, so it's obvious, but the left side is 0.514, and it's going to go all the way to infinity.